So before we jump into the topics in your book, we're actually going to cover a few things the book doesn't hit on, but we found them to be sort of important things that need to be reviewed, or maybe gaps from what you ended with in 8th grade to what you're starting with and what you need now. So we are calling it Chapter 1A. So you'll see on the notes it says Chapter 1A. On your worksheet tonight it says Chapter 1A. So there will be a regular Chapter 1. This is just sort of a pre-chapter to Chapter 1. So you can go ahead and just start in the top box on your notes. This is the commutative property. So you already have the first two columns filled in. Then we're going to fill in some examples. So the commutative property works with both addition and multiplication. I'm just going to throw up all the examples and then we'll talk about why they're important or what's going on in each. Bless you. So commutative property of addition, commutative property of multiplication, pretty much same thing. The addition one has plus signs, the multiplication one has multiplication symbols. The only thing that changes when you're using the commutative property is the order. Now the way I remember this one is, do you guys know what it means to commute? Yeah. Commute, like your commute to work, your drive from work. I live in Columbia. Every day, I start in Columbia. I end in Belleville. At the end of the day, I start in Belleville. I end in Columbia. Have I driven a different road? No, it's the same thing. I travel the same miles. I see the same houses. Nothing has changed except the order that I'm driving. All right? Same thing happened in the commutative property. If you start with a 3 and you add a 5, it's going to give you the exact same thing if you start with the 5 and then you added the 3. Okay? Now, pay close attention to the parentheses. There is a property that involves parentheses, but those parentheses move around. Here, the parentheses have not moved around, and what's in the parentheses hasn't changed, just the order is different. So if, for example, the parentheses would have been around, let's say the 3 and the 2 here instead of the 5, that's a different property. But since the 3 is on the outside in both, and then the order just changed of what's going on inside the parentheses, that's why this is still commutative. All right? And you can see it works for multiplication too. They went 3, 5, 2, then they went 3, 2, 5. Same idea, commutative property. What are your questions? And you don't have to write this down. This is basically what I just said. The order in which you add or multiply two numbers does not affect the result. Sort of like driving. You're driving the same road either way. Doesn't matter where you start in your commute. All right, here's the associative property. So once again, you have the two columns already ready in your notes. When you're adding, it looks like that A plus B in parentheses plus C. If you move the parentheses around, keep them all addition, you get the same answer. All right? And here it is with some numbers instead of the letters. You can go ahead and write those down. Now, do you guys know what it means when you say like, oh, I associate with that person? Yeah, it's kind of your friend, right? It's who you kind of hang out with, your associates. Same thing here. If I have the 3 and the 5 hanging out, and then all of a sudden the 5 and the 2 are hanging out, you still get the same answer, okay? Whoever you're associating with in your parentheses, as long as all the same numbers are still in the problem, it doesn't really matter who's grouped with who first, okay? That's sort of the PG way to remember this. I have a PG-13 way, too. Are you ready? Yeah. You can't tell anyone. Okay. We're not going to say anything out loud, all right? What are the first 3 letters of the associative property?
Pass.
Oh, I just said we're not going to say it out loud. Come on. If you take a pair of parentheses and you put them like this, what does it look like? If I took a pair of parentheses and I flipped them, I took those and I flipped them and I drew them right next to each other, what does it look like?
Adv Ch.
Huh? See it? Kind of looks like a butt. The first 3 words are... No? Okay. If that helps you, great. If it doesn't help you, throw it out of your memory. That's always the way I remember this, though. A lot of people get commutative and associative mixed up. All right? The associative property is the one with the parentheses. The commutative property is the one where the order is changing. If that offends you, I'm sorry. Push it out of your memory. Don't tell your parents. Thank you very much. Any questions? All right, and here it is just written out in words. The more appropriate math teachers all agree upon it. When your grouping changes or when your parentheses are moving locations. All right, next property. That's the only really funny memory trick I have. Sorry, the rest of them are kind of, it's all downhill from here. These are the properties of equality. There are 3 of them. Reflexive, symmetric, transitive. I will throw them up here for you with some numbers. And then I do have a memory trick for this one as well. It's not as entertaining. But when you're ready, I'll give it to you. All right, so the reflexive property, it's kind of like looking in a mirror, right? When you're looking in a mirror, you're looking at yourself. But it has an X, it's not reflective like a mirror, so that doesn't really hold up. It's not perfect, but it helps you. If the A is looking at itself, boom, it's the reflexive property. You can have more than one thing, though, so like if you have the 2 plus 4, it's just 2 plus 4. You don't change the order of anything. Same thing on both sides of the equal sign, all right? Symmetric is the same thing on both sides of the equal sign, but the order changes. So A equals B, B equals A, same thing. 2 plus 3 equals 5, 5 equals 2 plus 3. That's the symmetric property. And then transitive property is where you're cutting out the middleman. If A equals B and B equals C, you can cut out those B's, go right from the beginning A to the end C. My memory trick for this one. In the alphabet, these are in alphabetical order, right? Okay? 1, 2, 3. How many things are involved in the reflexive property?
2.
1. It's the same thing on both sides, right? And here, technically, there are 2, but they're kind of a group, right? Nothing's changing. It's just one thing on both sides of the equal sign. Symmetric, you're now involving 2 things, A and B, B and A. That's the second in the order in the alphabet. Transitive property, RST, that's where you have 3 different pieces. Okay, you have an A and a B and a C. So for the properties of equality, if there's only one thing involved, reflexive, 2 pieces involved, symmetric, 3 pieces involved, transitive. Like I said, not as funny or as memorable as that first one, but hopefully still kind of helpful when you're drawing a blank on these. Questions? All right, substitution. There really isn't there's not multiple types of the substitution property. That's why there's nothing really here. Substitution is substitution. It's when you put an equal amount into an equation or an expression. So in this one, for example, instead of writing 3 plus 6, they're just writing a 9, because 9 is the same thing as 3 plus 6. You're taking something out and putting something equivalent in. Sort of like a substitute in a sport, right? Like number 3 in for number 5. You know what I mean? Hopefully the players are equal. You're not taking out a worse player for a better player. You know what I mean? You're hopefully just a substitute. Or when your teacher's sick, you get a substitute teacher. I'm sure none of them will be as wonderful as me, but in theory, they're supposed to be equal. Questions? All right. The identity property. All right, your identity is who you are, right? Okay, it's what makes you you. So in the world of addition, if you're not trying to change someone's identity, what do you add? A 0, not changing anything. In the world of multiplication, how do you keep a number's identity?
A 1.
You multiply it by 1. So you're not changing the value of the number stays the same, but you are still performing an operation. You're adding 0 or you're multiplying by 1. All right, inverse properties. The inverse properties are the properties that undo each other. So if you add opposites, they undo each other, you get a 0. If you multiply reciprocals, that's where you take a number and you flip it, you end up with a 1. So they're operations that undo each other, inverses. So 5 plus negative 5, you get a 0, the number goes away. Again, in the world of multiplication and addition, you have different results. Adding 0 is considered canceling out. And multiplying and dividing a 1 is considered canceling out. And you got to remember, and hopefully you do, that any number, whoops, hold on one second. Every number is a fraction, you just might not see the denominator. So 5 over 1, flip it, 1 over 5. That's when you multiply by the reciprocal. All right, next we have the multiplicative. That always takes me a second. Multiplicative. You try. Multiplicative. Isn't that fun? Multiplicative. Okay, basically when you multiply by a 0, when you multiply anything by a 0, you get a 0. There are not, this doesn't work obviously for anything but multiplying. That's why there's nothing under that title. But basically any number times 0 is 0. A multiplicative property of 0. All right, and then the distributive property. Once again, there's only one type of distributive property, so there's not a series of different names in the first box. The distributive property says if you have a number multiplied by a quantity with either addition or subtraction inside the parentheses, you can multiply each of those pieces by that number out front. So A times the quantity, B plus C, is the same thing as A times B plus A times C. And here it is with some numbers. So if you're adding some number A plus 5 and multiplying that result by 3, you could multiply the A times a 3 and the 5 times a 3. And then you keep whatever symbol was in the middle the same. So if you were adding, you're still adding. If you were subtracting, you're still subtracting. All right, those are the properties. So go ahead and flip to the next page of your notes. So if x equals 2 and 2 equals z, then x equals z. What property is that?
Reflective.
Nope. This is the transitive property. Good. It's one of the properties of equality. And then I always notice there's 1, 2, 3 things involved. RST, transitive. And then the transitive, in other ways, I always think of it as cutting out the middleman. All right? If they both equal 2, they equal each other. Get rid of the 2. Old news. All right, part B. What's moving around? Yes. Yes, your parentheses are hopping. And make sure you double check. Sometimes we'll move the parentheses, but the number inside the parentheses didn't change. Then it might be a variation of the commutative property. But if you're actually putting different numbers in those parentheses, it is the associative. Good. Associative property of addition. Good. All right, part C. What's happening? Distributive, yes. You have a quantity in parentheses being multiplied by a number out front. You can multiply each of the terms inside by that number out front. That is the distributive property. Part D. Huh? Somebody said it. Commutative property of multiplication. Good. If you start at X and you end at Y, start at Y and at X, you get the same answer. They're equal. That is the commutative property of multiplication. Whoa, sorry. My iPad slipped and the answer popped up. If you have 7, you multiply it by the reciprocal, you end up with a 1. It's undoing the 7, turning it into a 1. That's the inverse property of multiplication. All right, here's F. So this is one of those that I sort of warned you about in the last slide. You can't just see parentheses and automatically think, oh, that's the one that she talked about with the dirty word, and I'm just going to write that. It doesn't quite work like that. It is a helpful hint, but it doesn't work like that because the numbers in the parentheses aren't different, right? We had a 2 and a 3, then we have a 3 and a 2. For it to be associative, the parentheses would have had to group a different number. So associative is not going to work here. What is happening though? Yeah, the number and the parentheses are the same, but the order of the number is different. So this is an example of the commutative property of multiplication. So tricky. While I do think the but trick is helpful, it is not an end-all, be-all. You still got to think a little bit. Have you guys heard that trick before? Mm-hmm. Someone told me when I was younger, and I just kept it rolling. It'll catch on one of these days. It'll be in a math textbook soon. Probably not. That would be an awesome textbook. I would for sure buy it.
Great, thanks to Miss Linda.
Yeah, I didn't come up with it. I'd have to think. I don't want to call the teacher out, but she works at Freeburg. All right. Identify the property. So instead of writing out 4 plus 1, I'm writing out something that's equivalent.
Substitution.
That is the substitution property. I am substituting a 5 in for a 4 plus 1. All right, H. If A equals 2B, then 2B equals A.
Symmetric?
Do you guys know the answers back there? I hear you talking a lot. Yeah, what is it? Nope.
Inequality.
It's one of the equality properties. Someone has said it. It is the symmetric. Once you've narrowed it in on those equality properties, remember if there's one thing involved, it's symmetric. Same thing on both sides. If the order of what's equal flip-flopped, that's when it's symmetric. Good. And then transitive is when you cut out that middleman. Okay, 3 equals 3. Reflexive. Yep. Reflects with an X. Yes. I referenced the mirror. The mirror is reflect. I know it's a bad reference. It confuses people on the spelling. It is reflexive. All right, 10 times 0 equals 0. The what? Multiplicative property of 0. I am impressed.
I got a question.
Yes.
Do we do irate?
Do we do what?
Irate.
Irate.
You don't know what irate is?
Nope, you're speaking gibberish. Okay, if you have a 6 and you add a -6, they both go away and you get nothing. That's the inverse property of addition.
No.
Almost there. Don't put your notes away after the next example, though. Okay. 5 plus 0 equals 5. The identity property of addition. Phenomenal. Now, I end every day of notes in the exact same way. Okay? So when you're all ready, I will show you what you need at the bottom of every single day of notes. You need the sentence, today I learned. And then every day we're going to finish that sentence together. Today I learned all at the bottom or along the side, sometimes in the front, anywhere where you can squeeze it in. Thank you. Today I learned about what did we talk about today? The properties. Good. I guess you could cut out the word the. Today you learned about properties or the properties of algebra. I learned how to say a bad word, you know.
Actually,
Something like that.
No one else did.
All right. I am going to give you a real quick activity and then we're going to get to homework, okay? Any questions?
Wait, we got homework.
Of